Hi ladies, and welcome to a little bit about currents and climates. Don't forget to use your worksheet to answer the questions as we go along. What do sneakers, rubber duckies, and the ocean all have in common? Currents, oddly enough. So let me tell you a little bit about this. The sneaker incident was very similar, so I'm just going to tell you about the ducky story. But before I tell you a little bit more about it, there's a song I think that you will find interesting um, and a little video to go along with it. As you're watching, I want you to be thinking about what happened, what did people think what happened to the rubber duckies, and then what actually did happen to these ducks.
In the winter of '92, a Chinese freighter was crossing mid-Pacific. A storm came up, rocked the boat, causing damage that was quite specific. A shipping container marked first year slid portward with gathering speed. It hit the rail with a great thud, split open and fell into the sea. Oh my God, said the first mate, as the flotsam was beginning to grow. A great armada of rubber ducks was bobbing in the ocean below. They drifted off to the northeast, all formed in a line. Don't worry, said the captain, they'll sink, everything will be fine. They'll sink, everything will be fine. 29,000 ducks floating in the ocean. Into Earth's biggest bathtub they did dive. Yellow rubber ducks heading to Alaska. No one ever thought they would survive the ocean tide. 9 months later, a fishing crew was puzzled by what they found. Dozens of yellow rubber ducks swimming in Sitka Sound. The oldest city in Alaska, that's where they washed ashore. 80 miles west was the rest of the flock, some 29,000 more.
And so I'll leave it at that. So as you can see, there was a bunch of rubber duckies that ended up getting tossed into the sea accidentally. And because of this incident, we have a really good understanding of currents now that we didn't have before. If you look at this little map here, you can see where the rubber ducks first landed in the ocean, and then you can see where all of them went about. They ended up being tracked where they were found, and as you can see, they were found first in places like Australia and then over into South America. But then from there, they're basically found in every other continent. So over here, North America and the United States, and then later on in Europe over here as well. And then finally, on the other side, even on the east coast of the United States, where nobody thought that they would see these rubber duckies lie. And from there, we learned a ton about the currents and how they go. So what is a current anyways? Okay, so it's a large stream of water that flows through the oceans. Unlike the waves that we've been talking about, currents actually move the water. Even though waves don't necessarily move the water, if you remember, they travel in small circles, right? But because of currents, currents actually do push the waters. So there are two types of currents. The first one is a surface current, and then the other one is a deep ocean current. So let's take a closer look at each one of these. Surface currents are mainly affected by water. by wind. So the water is affected by the wind. And what you'll find with something we'll talk a little bit more about is the water is affected from the top down to about 100 meters. And then from there, the deep ocean currents take over. So they usually move in a circular pattern, these surface currents. And you'll find that in the north half, or the northern hemisphere of the world, they kind of curve to the right, these currents. And then the opposite is true, that they curve to the left in the southern hemisphere. So I want to show you a little bit why they curve. Why is this thing coming? Well, it's something called it's the phenomenon called the Coriolis effect. Okay? It deals with the effect of the Earth's rotation on currents. So to give you an idea of what's happening, I have a little video to show you to give you a better understanding. So what happens is the water is actually moving in a straight line, but it gives the effect of moving in this circular pattern. So what you're going to see here first is these two gentlemen that is just throwing the ball straight. They're showing you the angle doing it straight, and then they are going to throw it. You're going to see it throwing from the top angle when it's not in this spinning mechanism that they have, and then also when you are part of the mechanism, and you'll be able to see the difference. Okay. So here they are, they're just throwing it straight like normal. This is how they're going to try and throw it every single time. But why is that happening? Let's fast forward through it just a little bit more. Let's see if it will take it. Oh, of course. Okay, notice they're trying to throw it straight. See, as you're looking at it from a top, it's throwing from a straight angle. So now you see it, now you are attached to what they are actually on. Now look at its movement. What do you notice? Do you see how it's curving in an angle? It actually has the appearance of curving in an angle. So that's kind of what we see, and it's called the Coriolis effect. We'll talk more about this in class. Then the second type of current is a deep ocean current. So here is how this kind of works. So these currents are actually caused by the difference in the densities of the water. There's a couple of things that depend upon the density. I know we've talked about that word before. You should remember things that are less dense rise up to the top. Things that are more dense sink down to the bottom. If you remember back to when we were talking about the inside of the Earth and convection currents, very similar to that. So here we have these waters that are mixing around the world. So this is kind of how they do it. First you have these surface currents, and they're the warmer currents, and they start from the equator, which is here, okay? And they are traveling towards the pole. As they get closer and closer to the pole, it gets colder, saltier, denser, and therefore, when it becomes dense, what does it do? You got it, starts to sink. And they become these deep ocean currents. So these deep ocean currents actually now start moving towards the equator. Well, what happens as you're moving towards the equator? It gets warmer, less salty, and then starts to rise. And so then you get these currents flowing throughout the whole ocean. Now, it's important to remember that this takes a long time to happen. It might take up to 1,000 years. Okay, so just as a quick review, what causes surface currents? Okay, you got it, winds. How about deep ocean currents? What causes those? It's a little bit different. All right, good. The differences in ocean water densities. So now the last thing when we were talking about currents that occurs that helps us out a lot is called upwelling. So it's the movement of the really cold, deep water up to the surface. And this happens because we were talking about winds and how they move or put their energy through this ocean water. So sometimes there's so much wind, it kind of whisks this top portion away. And when that happens, this colder water comes up to the surface because as we know, water is a liquid and liquid always takes the form of the object that it's in. So it's not just going to leave that place empty. The cold water comes up in the bottom to take its place. Now the thing with this is that along with the water, it brings very important nutrients with it so that most of the animals that live up in this water have the nutrients that they need to survive. So without this, the ocean water would be very scarce in nutrients and therefore probably animals as well. You can kind of see in this red zone where these upwellings usually take place. And so then I'm just going to leave you with a quick little video about how everything goes together.
Is the major system that carries heat in Earth's ocean. The heat transport of this system helps to moderate Earth's climate. This model shows in a simple way how heat is transported from the low and mid latitudes to the far North Atlantic. Shallow currents are warm and shown as red. Deep cold currents are colored blue. The moving pulse shows the general direction in which ocean currents flow. Cold, deep currents travel east past Africa. Some part of the flow rises in the Indian Ocean. The rest of the cold current continues flowing toward the North Pacific Ocean. In the Pacific, the current becomes warmer and less salty and migrates as a surface current toward the North Atlantic. In the North Atlantic, dry winter air cools the ocean surface. This removes heat from ocean waters and makes them salty and dense. When this water sinks to great depth, the global conveyor belt again begins its worldwide circuit. The entire process takes as long as 1,000 years to complete.
So how are these currents, how do they help with the climate? We'll talk a little bit more about that in class. Thanks for listening, and I'll see you next class.